Hannah and I am a psychology graduate from the University of Nottingham, and today we're going to be talking about the human brain and all the ways that it can change and grow as we learn. So what is in our brain? So your brain is made up of lots and lots and lots and lots and lots of cells called nerve cells or neurons. You have a whole system of neurons in your body, as well as the big massive clump of neurons in your brain. These neurons send messages to each other very, very quickly in order to help your body do all of its functions. So if someone stands on your toe, you're going to know really fast that that hurts. And that is all of the little neurons sending messages to each other from your toe all the way up to your brain. So what does our brain do? So every single part of your brain has its own specific job. So we have a bit over here for seeing, a bit over here for hearing, a bit for talking, a bit for all of the functions that you do. And when we use these pieces of our brain lots and lots and lots, we get really good at using them. So what happens when we get really good at using them? Imagine that your neurons are bricks of a path. So when we first learn something, these bricks are tiny, wobbly stepping stones. But the more that we do something, the better that we make these paths. So we can build them into lanes, we can build them into roads, and then we can build them into big, long motorways. And it's then going to be a lot easier for the messages to travel down the paths if we have built them up to be really, really strong. So, lots of things can change our brain, and one of those is video games. So one study found that people that played Mario Kart every day for 30 days had a change in their brain. So the parts of the brain that they used for reaction times and navigating and spatial awareness and their visual system, all of those parts of the brain actually grew bigger. So we had more and more neurons come to the bit that we used to build those pathways up so that they were really, really strong and they did better at playing the game. So if we use a part of our brain over and over again, then it grows. And this is really useful because that means that we get better at stuff. So when you hear people say practice makes perfect, practice makes your brain grow. So how did we find all of this out? How do we look at the brain? So years and years ago, the only way that we could look at the brain was after someone had died. So we would cut the brain up, dissect it, see if there was anything wrong with it, any of it look a little bit dodgy, or does it look like everybody else's brains? This is called a post-mortem. So post means after, mortem means death. So after death, we would look at someone's brain and see if there was anything a little bit dodgy that we might be able to see why they couldn't do something when they were alive. So one example of this was in the 1800s on a man named Tan. So he was nicknamed Tan because he couldn't speak. He could understand things that were said to him, but he wasn't able to say words back. So a scientist called Broca conducted a post-mortem on Tan's brain after he died. This showed that there was a specific part on the left side of his brain that was damaged. So they looked at the brain and they thought, that bit looks a bit funny. I wonder whether that was why he couldn't speak. So this dude named the area of the brain that he discovered after himself. So we now have a part of the brain on our left side, right about here, that is called Broca's area, and this is responsible for speech production. We have since looked at this in fMRI. So these are the big brain scanners, and we can see the activity in our brain on people when they are alive, and we have seen that yes, this is the part of the brain that we use when we speak. So what we learned from these kinds of studies was that if we damage a part of the brain, we might then lose the ability to do whatever it was that that part of the brain was able to make us do. So if we damage a certain area, we lose the function. There was another dude a very unfortunate event that happened to Mr. Phineas Gage. So he was a railroad worker and he was involved in an accident where there was an explosion and this metal pipe hit him in the head and it went straight through his cheek, out of his eye, straight through his brain. And somehow he survived this. So you can see that little picture, you can see how big that rod is, the holes that it made in his skull went straight through his brain, and somehow he survived. But what was different about him after his accident was that he was really, really angry, he was rude to people, he behaved really recklessly, and everybody that knew him said that he had changed after his accident. So what had happened was that when the pipe had gone through the brain, it had gone through what we call the frontal cortex, so that is this part of our brain. And this is the bit that has our personality. It controls our emotions, it controls our actions, and this part of the brain in Phineas was damaged. So that meant that his personality had changed, and he was then unable to control his emotions, control his actions, so then he was rude and reckless. So we can see from cases like this that if we damage a part of our brain that is responsible for something, then we might lose the ability to do that. However, there is the chance that we can recover from brain damage. So whilst this is not something that you want, the brain is rather clever and it is able to make at least some recovery from brain damage all on its own. And this might be that if we damage a part over here, then a different part of the brain that might be over here will take over that function so that we are still able to do it. We just might have to use a different part of the brain to do that. So there were some cases. For example, we have a woman who was born blind, but she was reading Braille from age 7. So she was not able to see, but she used her fingers to read dots, which is a Braille system which enables blind people to be able to read. So she could do this no problem. And then when she was older, she was in her 60s, she had a stroke that caused damage to her brain. And the area of the brain that was damaged was right at the back here, where our visual cortex is. So our visual cortex is the area of the brain that is responsible for interpreting things that we see. So you would think that this woman wouldn't need her visual cortex because she can't see. So she has something wrong with her eyes that means she can't see. So why would she need part of the brain that interprets visual information? So you would think that she was fine and that she wasn't affected by this. However, this wasn't actually true. So this woman found that she couldn't read Braille after she woke up from this stroke. And this was very strange considering where the damage was. But it turns out that the woman for her whole life was using her visual area in order to read Braille. So when she was learning Braille, she had all of these neurons at the back of her head in the visual cortex that weren't doing anything. So they thought, well, we may as well do something and we may as well learn a skill. So all of those neurons were recruited into her learning Braille. So that means, unfortunately, when she had damage to this area, she then lost this function. She did eventually gain some of that function back, which is great. And it does show that our brains are able to swap jobs with other areas if they need to. So if she had a working visual system, she wouldn't have needed to use her visual cortex in order to see, in order to read Braille. She would have just been able to use it for normal visual tasks. And it wouldn't have swapped jobs, but because she couldn't use it, all of those neurons were there anyway, so they were used for something else. So if it is necessary, our brain can actually swap jobs with another bit in order to help our human body function in the best way possible. So the way that our brain can do this, it can change what jobs each part does. It can grow it can look different depending on what we've done. This is known as plasticity. So imagine that your brain is like plasticine. So we can mold it, we can shape it. As a result of experience, our brains can change. So we can see that if we play Mario Kart, parts of our brain get bigger. If we damage parts of our brain, then other parts are able to take over. So this is a really useful function. But how does it work? So if we go back to neurons as paths, when we have damage to our brain, we now have a block in the road. So we now need to take a detour. So we can go another way, we can go the long way round down some back country roads. So we'll use some other neurons from other areas. Or maybe we've got some spare neurons, let's build a bridge over the damage, or let's repair the damage so that we can still get to where we are going, but we might have to take a different way. And that's what happens in our brain when we've got damage. So it can't go and send the message from A to B because there's damage somewhere in the middle. So we'll find another way around. And this is really good when we are younger. So we can have plastic brains throughout our whole life, but plasticity is really, really good when we are young. So we can see this in lots of cases. So there was a case where one boy had the whole left side of his brain removed when he was just 2 years old. So originally, he did lose the function to speak. This is because the area of the brain that we saw was involved in helping us speak was on the left side of the brain. So when that whole area was taken away, he initially lost the ability to speak. He also lost the ability to move the right side of his body because our brains are actually swapped over with the side of the body that they control. So the left side controls our right side and the right side controls our left side. So when he had the left side of his brain removed, he might have had trouble moving his right side of his body. But when he got older, he was completely fine. So he was able to function normally, he could speak, he could move perfectly fine. There wasn't really anything that you could see that was different, but he only had half a brain. And this was because the right side of his brain that was still there had taken over all of the jobs that the left side of the brain has done, which is really clever. So what we can take away from this is that we exercise our brain to keep it healthy. We can do lots of fun things. We can keep learning, we can keep being creative, we can keep playing video games. Learning all of these facts today has made your neurons work super hard, and this is really good for our brain. We're strengthening all of those pathways, our brain is changing, and it's keeping us really healthy. And if we have damage in the future, it is easier then for our brain to repair itself if we are using it more and more and more before the damage had happened. So if there's any excuse, look out for more sessions on the brain coming this week. Bye!